Hello guys, so I'm making some upgrades for my PRUSA MK4 and I thought I'll share my experience with you. I'm going to be aiming to replace all PETG parts with these parts that I printed from ABS Plus. So this is going to be partially a filament review, high level, and this is a bit of midway through the project video, well, 1/3 in, because I already replaced all these Y gantry parts, and I did this partially because it was making very loud noise, very loud grinding noise. And to be honest, I'm at the moment still figuring out why it didn't help, because I also replaced bearings with original Misumi bearings. So yeah, maybe there's a bit of work that needs to be done with adjusting the belt with the pulley and the idler, or idler, don't know which is the right way to call it. Then another small upgrade what I'm going to be doing is, so this is a typical your heater block that comes with PRUSA. This is it weighs 6 grams, yeah, this is aluminium. Now in the aftermarket you can get these ones that are 20 grams, so this is like plated copper. So as you can hear, this is heavier, so idea is it should retain heat, like trap the heat in the nozzle more evenly. I don't know if it's if it makes sense. I'll try. I got it, why not? Then another thing that I'm going to be doing is I'm going to be replacing these original bolts with these high tensile steel bolts I got from Accu. Why I'm doing this as well, I just think that these are not very precise bolts and I don't know where they made. So to have the best rigidity for the frame, I would like to use these ones that are, I think, you know, I know that they're made in Europe, they're good quality, so why not? I'll tell you if it was worth it in the end. And yeah, and obviously I'm gonna talk you through this filament. It's a very good filament. It's an engineering grade filament from BASF. It's one of the Ultra Fuse series. It's ABS Plus. And yeah, I'll talk through all of that in a little bit more detail. So these are original PRUSA parts that I have already removed and replaced. And why I decided to replace them is for a few reasons, because basically there's an update, like a revision 2 of all of these parts. So if there were initially some design issues with them, PRUSA have fixed them, and now they are available for download from Printables. So as you can see on some of them, you can see like F1, so that's like probably, you know, round 1. And on all of these parts that we are going to be reprinting, you have the R2. So as I understand, it means revision 2. I don't know what the F stands for on the original ones, but basically revision 2. So it's like hardware update for the original ones. Probably doesn't make much difference, but you know, it's I think as I am aware, there are some issues with like TPU printing and some parts in an extruder. Maybe we should improve that. But why I'm also doing this is because these are just 2 layers, 2 perimeters, and like 20% or something infill. So you know, like if you own a print farm, of course you want to maximize your, you know, part prices. So it makes sense, PRUSA does that. But if you want the best for yourself, you know, more rigid parts, I googled Warren printing printed part settings. So it's like much more robust. So it's like 4 perimeters, 40% infill, like top and bottom layers, also like 6 or 8. I'll share my settings with you guys later. And of course, the main reason is that these parts are ABS and this is PETG, so the heat resistance is going to be much better. So because I want to be experimenting with, I don't want to be limited basically just PLA and PETG. I want to try to do some ABS, ASA. I already did some PC, but because summer's coming and I'm using enclosure, I think if the temperature, you know, rises too much, then parts will start deforming. There is some information already about it online, so just to prevent that, as long as I have time, this is just a project that I want to do. So that's the reason basically. But Now let's talk a little bit more about the material itself. This is how you're going to receive your filament. It's just basically a cardboard box wrapped in a cling film or saran wrap if you're from the US. And inside it's this spool. I don't think they have bigger sizes, so it's just 750 grams that they're going with. And you can find settings for these in PRUSA Slicer. Of course, I modified them because they didn't really print that well in the beginning. In terms of not that they didn't print well, but there were some issues regarding bridging. And yeah, so you have to still do a bit of your own kind of testing. So that's why these parts are for here. So let's just go into a little bit more detail. So if you just go with pretty much slicer settings for this material that PRUSA Slicer has for you, your bridge is going to be a bit shit. Also, this material's sticking to the plate properties are like sick. Yeah, so I'm using this satin powder coated sheet, and without anything, if you print these parts, you know, they bind so well because this is ABS plus. So ABS plus is basically maybe I'll have details for you what they add to original ABS filament, but they improve the printability of it, so it warps less, and you don't have that much problems with the interlayer adhesion, so it should be stronger parts. And they are also heat resistant to, like, they're not as heat resistant as the original ABS, but as a trade-off to dimensional stability and stabilized warping, you get parts that are still acceptable in the Voron community. So Voron community says that you can print all your parts with ABS plus. So if it's suitable for Voron, I think it should be suitable for all the other printers as well. That's why I'm going with these ones. And so about the stickiness first. So basically, if you just print those parts, and sometimes when you remove them, you see you're gonna have these problems when some of these layers will pull out and kind of destroy a part. You know, like maybe this is still okay-ish, but some of them like literally rip layers apart. And especially if it's thinner parts, look what's gonna happen when you're gonna be trying to remove it. Yeah, so basically this part is just not usable anymore, because when I was trying to remove it from the plate, it yeah, I destroyed it. Some other parts too here, right? You see, it has this kind of white, looks a bit like Emmental cheese or Parmesan cheese, kind of a white, I don't know how to call it. Yeah, this type of whiteness, like a chalk, like you have those on the cheese. And yeah, you pull these layers out also. So I don't want to use, you know, printed parts like that if I'm replacing it on my printer. Yeah, like it's just not gonna, you know, you don't want to do that. So some of them you can remedy with PRUSA Slicer settings, and some of them I'll show you how to treat easily with some sort of a heat gun. Take a part that has that white gunk on it, and let's just focus the camera on. Yeah, and then I have this kind of a heat gun I just ordered. You can use any sort of ones, but let's see. Okay, yeah, so if you have something that's kind of smaller scale, I think it will help. But basically, you just slowly go over the surface, yeah, see, and then you just kind of making this part not as ugly anymore, right? Now it suddenly doesn't look that bad. And the best is that ABS, why I like ABS is because it is very, very easy to sand it. It's like pleasure to work with it, like to post-process it. But of course you want to, you know, avoid this whole post-processing to a minimum, and it has to start with the right slicer settings, because once you start with the right slicer settings, then you can just easily clean these little white bits, and you have perfectly looking parts, which are parts like these. So this is my second batch. It took me like 2 days to print it, but I think I kind of nailed it. I didn't have many issues with that, with this batch. There were a few issues, but mainly they like printed like really awesome. Like, I really can't express enough how satisfying it is to watch at a material that is heat resistant, robust, easy to print, and not very expensive, and easy to post-process. Yes, finally, industrial grade quality material that you can print at home. Just look at this. Of course, I'll do more testing than just these parts later if everything works, if my printer still works after I'm done with it. So, okay, you need PRUSA slicer settings for that, but you also need a release agent, because if you don't use this release agent, then you are risking to get these parts that will look like this. That's the short answer. Okay, so I'll get working, and let's see how this printer looks further in the project. And just one more thing, guys. Basically, it's an improved version of ABS, but it still shrinks. So it still shrinks more than PETG parts, for instance. And this is worth keeping in mind, because when I was printing original parts for the Y gantry or axis, I'm not sure what's the right word for it, axis, let's say, I printed them like at the scale of what the original part was from Printables, so I didn't change anything. And the material shrank, but I still managed to, you know, assemble it. And maybe that's part of the reason why I'm still having this grinding noise, some people might say. And maybe that's the case, and maybe I'll later reprint them at a better scale and replace again. But for these new parts that I'm gonna use for, you know, the X and the Z axis, they are scaled by 0.5%. So I printed them at 100.5% scale to compensate for the shrinkage. And I hope it's gonna be right, because otherwise I'm gonna have to reprint everything again, which, you know, is, I wouldn't like to do that. So yeah, let's see. And for bridging, you know, it's just very little amendments that I did in the slicer, and managed to get these bridges almost perfect. So this is like, I think, 10 millimeters per second speed. I could have reprinted it with even smaller speed for bridges, but I think it should be alright. I'm good with it. These type of imperfections is very easy to fix. So I still haven't processed all these parts, so some of them, they need a bit of a solder touch-up, maybe some of them just a hot air blower, but overall it should be nice. This is how it looks with all the bolts replaced. This was, I guess, easy bit of the project. This is the back side. I also did play around a little bit with the idler and pulley at the back. So yeah, when manually operating, at the moment I really cannot hear any grinding, but you never can. So I'll try to put this printer back in the enclosure and see if I can hear any improvement. So to my disappointment, it's just bad. So I bought this printer assembled, and some people in the forum says that, you know, sometimes bearings come kind of faulty, or you know, if there's some little balls that are inside the bearing that are missing, that will cause this, I don't know, this issue of grinding noise. But you know, just imagine how loud it is when you're printing something fast. So bad. Yeah, I'm, to be honest, disappointed, because the printer is like not very cheap, and even after replacing bearings, it just leaves me thinking that, well, what else could it be then? Like, maybe it's the smooth rod that is kind of a little bit bent or something. Maybe it fell down when they were installing it, for example, and you know, it causes this resonance. But whatever it is, it's very hard to detect. And so yeah, let me know in the comments, guys, for this particular issue, if you managed to somehow sort it out. I have now finished processing all these pieces, and just before I'll start this assembly exercise, just wanted to share with you how it looks like when it's all cleaned. So of course not all parts came out perfect. Not gonna lie, because this is partially filament review as well, as I told earlier. So as you see, for instance, here I have like a little warp, but like here where two parts join, you can see there's also a little warp, but I guess it's kind of unavoidable unless I don't use this release agent. Yeah, it's a, you know, I'm not saying that this is the best set of parts that you can have, by no chance, but I think it should work. Like here I had a bit of warping around the edges, but you know, if you put the part on the table, overall it's like it's flat. So that's all that matters. And these are pretty much the biggest issues with the parts that I had, that I'm showing to you. Other parts are like kind of perfect. Look here, so just a little bit of warping around the edges, but overall geometry and like rod opening sizes I measured with calipers should work. You know, a little bit tight, but you know, either I go with more than 0.5% of compensation, which I tested few of those. Like some people say that you should only compensate X and Y axis, because Z is okay, it doesn't shrink that much. But look, this is trial and error. So this part I showed you earlier, like for example, this one is impeccable. Looks complicated, but I guess it depends on the thickness of those parts, and sometimes if it's thin it warps, sometimes if it's around the, say here, and this is like a sharp kind of triangle end, and in the bottom had a little bit of warp, but structurally shouldn't matter because all this is flat, and this is actually where the Z engine or motor will attach, so that's flat. I think, you know, Prusa guys, they have it thought out so that there is deviation allowed for all these parts. So it will look, if it works, this printer will look like a bit like one of those old Prusa's prototype machines when he was just starting the i3 series, and that made him who he is now. Yeah, this part is important because this is next to the heated plate, so this is important, that has heat resistance, especially this part. And fan shroud also printed like no issues at all. Even if you see inside with where you had the bridging going, it's no problem, really smooth. So for example here, like no warp. So why didn't this one warp, others warped? I don't know. probably because of the way it's designed, I guess. But anyways, really great material, very good material. Let's see, for example, extruder cover, revision 3, perfect, no warp, nothing. Look at this, smooth. What else can I show you? Levers, like one of the smaller parts, like even this bit here in the middle, like no problemo. Once you add both of these parts, so this is lever 1, this is lever 2, like here, look, boom, perfect. I cannot squeeze it with okay, I'll try it with one, if I can do it with 2 fingers, because I'm filming with the other one. Here, well, I guess there is a bit of a gap, so if I really wanted to like be super specific about it, I could sand it a little bit, because at the top layer you see nozzle kind of still leaves a little bit of the surface that is not entirely flat. But hey, this is, I think this is, to be honest, much more accurate than the printer parts that I already have installed that came by default, so let's just go with it. I finally disassembled X-axis, so it's just right here. You need to do that in order to be able to replace MK4 parts, obviously. And you know, I'm trying to just replace them as I go. So like some parts like this fan and the fan shroud, they fit just fine. So just I'll just remind you that all these parts are printed with ASA Plus from BASF, and they're printed at 100.5% proportion. So this is to compensate shrinkage. But so for some parts it works, like this one had no issues, should work fine. Some parts that, you know, as long as I take something out, I try to immediately try if they fit in the newly printed parts. So far they do. Now when it comes to like sliding in the rods, so now because I disassembled I took out the X-axis, I can take the Z rods out, and I started fitting them into these parts, and you know, obviously not everything went according to my plan, and they don't fit like immediately. I could just force them in, but you know, I don't want to do that, because then it's practically, I'm risking either the part will fracture and crack, which I don't want to do, because then I'll need to assemble the printer again and print the part again. But because ASA has amazing quality of sanding, what I'm doing, I just take a pencil and I just use sanding paper. I'm using a 180 grit, so I'm just putting in the hole and then just sanding, and then it kind of works. Just applying average force, the rod goes in, and I'm just sliding, turning the rod, and I am able to remove it without like much force. See? And there is no residue left, right? So this is just once again. Oop. That's it, nice and tight, very nice and tight. Take it out, and now I'll show you the unprocessed part. So this is printed at 100.5, and you know, like here I try to push it in, but obviously I don't want to, like, I could of course support it on the table and give it a couple of hits from the top and it will go in, but then I'm not going to be able to take it out. So I don't know if the camera is going to pick it up, but here you see a little bit of kind of plastic is being pushed towards the bottom of it once I try to put this rod in. So pretty much this is the amount that I need to sand. Just one tip for those of you who would encounter this problem later as well. I noticed that the rod fits nicely on these sides, on this one and here, where you have the slit in the part. But so you need to focus mainly sanding here and this part here. So I'll do the second part, and then it's gonna be time to try to see how X gantry rods slide into new parts, which are a bit deeper, but let's see how these are gonna work. I'll keep you updated. It's time for check-in. So far everything's going pretty well. X axis is almost done. Now it's just hanging on the hook, because I've just inserted the Z smooth rods, and just wanna tell you how it went with the ASA print up until now. So I needed to sand this hole a little bit, I needed to sand this hole a little bit, and I needed to sand a hole for this and that rod too a little bit. For some reason these holes on the X mounted without any sanding at all. So I thought, you know, maybe it's the layer direction that has influence, but I don't think so, because both parts have been printed same vertical direction. And yeah, I think the color is coming out pretty interesting combination. I kind of like it, a little bit old school, very natural. And yeah, that's it is. Check in. Let's see how it goes later. This part here, yeah, has been replaced. This is the original one. And why I'm replacing it, as I said, PETG, tolerance for temperature. Have you seen this? This is already a deformation taking place. Yeah, so you can see deformation on this part alone, right here. Melted layer lines. And something weird going on here. So, I mean, look, it's probably not the end of the world and would have worked for a long time, no doubt. But still, like, depends, like, you know, maybe what if it just someday, you know, breaks, and then what? Like, you can't reprint a part, so you need to buy it again, put the same stuff inside that you know is gonna break again. You know, it's just, to be honest, for the price they should include better quality parts, I think. Like, keep in mind all of the, like, Ratrig V4 ABS parts come by default, so, you know, just saying. Anyways, beauty of it is that you can rebuild it, so not complaining. So far everything's going quite nicely. Assembled an extruder, had to clean everything inside. There was quite a bit of old kind of oil mixed with filament debris, so all nicely coming along. Just need to finish the cables and just changing the extruder, sorry, the heater block for the nozzle. I put this close to the microphone. This is when hardened steel meets aluminium, that's how it sounds. Squeaking, a bit of rattle. I don't want it. I want this. Metal. Give me metal. Why isn't this a default? Nice. This is money right here. PRUSA MK4 has now been rebuilt with the ABS parts. I finished assembling it last night. I think I really like how it looks like. Everything seems to have worked well, but I haven't yet connected it and tried it. Need to do all the calibrations and see if it's gonna work. I'll put it back in the enclosure now and update you. X and Y axis and Z calibrated just fine, but heater seems to have failed, and I tried it again, and it's probably because of this plated copper. So in the worst case I'll just have to remove it, but at least other tests passed. I haven't yet tested the extruder test. So it failed again, and I'm just gonna try to say that I don't have silicone sock applied, because I think it just heats too fast and it just thinks that something is wrong. So I hope that it works this time. It's going for the third time. Let's see if it's another failure. I really don't get it. Look, it's the nozzle temperature rising so fast. What is the problem here? So all the tests have passed except the heater for the nozzle, and I then manually am trying to raise it to 290 and no problem. So I just think that maybe there's a bit of time that it is calculated that it should heat through, and if it's faster or slower then it just says it's error, but it's actually not. So maybe just something to keep in mind. It doesn't matter if you choose your heater with silicone sock or not, it still fails. But an extruder testing passed, no problem at all. So I'll just try to print something. 10 hours into test print, that's halfway through. I'm printing the engine here. It's from this filament from ColorFab. Yeah, I'm still testing this one too, this filament. It's supposedly should have a little bit better qualities than PETG. It's dimensional stability wise, but yeah, I'm still trying to figure it out if it's the case. I mean, at least they have more colors to choose from than PRUSA, and more availability and free shipping. But yeah, otherwise printer's going pretty well. I'm printing slow, and I even slowed it even further during the print so that Y-axis would make less noise. So I'm in no rush. It's just few kind of desktop organizers and some cable organizers printing, so nothing too tricky. Yeah, so I'm just kind of doing this more like stress test to see if all these parts will stand up to the test. Yeah, let's check it back in the morning. Test print / stress test seems to have passed. I'll call it a day. It's 20 hours in. It's 95%. No chance it's gonna fail. So look, I'll just call it a day with this video. It's way too long already. I think some fine-tuning will still be needed to be done, like I will still need to adjust a little bit X and Z axis to try to minimize the friction. So pretty much what it means is that I will probably need to loosen up some of these screws to make sure that this rod, this dented rod, aligns more straight, because there's a bit of a sound now when the Z-axis moves up and down, so that's not ideal. And I think to reduce the sound for the Y-axis, I think I'll probably also need to loosen up bearings, although I have to say that I have barely tightened them already, so maybe it needs to be loosened even further. But look, it's just my speculation here. So either way, I hope if you need to redo your own PRUSA in ABS Plus or any other filament, this video will be helpful for you. So thanks for watching, and have fun printing.